cone just fits inside a sphere of radius 10 centimeters. The height of the cone is h centimeters and the radius of the cone is r centimeters. O is the center of the sphere, so the radius of the sphere is 10 centimeters, but note that this r here, which is the radius of the cone, is not 10. This is not a radius of the sphere. Show that the expression for the volume of the cone can be given by this. Well, we know that the volume of a cone is 1/3 pi r squared h. So the 1/3 pi we can't do much with, those are just constants, but the r is this, and we know that we've got a right-angled triangle here. Now what I'm going to do is just draw in a hypotenuse on this right-angled triangle. So this is a radius, so its length is 10. It's also the hypotenuse of this triangle. So from Pythagoras' theorem, r squared plus x squared is equal to 10 squared. So r squared can be written as 10 squared minus x squared. Then if we look at this length here, from O to here is 10 and this is x, so that's going to be 10 plus x. Now you clearly need to be showing where these are coming from by reference to the diagram. Once we've got that, we've got 1/3 pi 100 minus x squared 10 plus x. Now even if you didn't get this, you can do the second part because we're actually given the formula. We want to find the exact dimensions of the cone which has a maximum volume, and we need to justify that answer. Now it's a calculator paper. So we want to find where we get a maximum, so we need dv dx is equal to 0, and we can do that with the calculator. So action, advanced, solve, and then we want it equal to 0, so 0 equals, and we could use one of these templates here. So we're going to do d dx of 1/3 of pi times 100 minus x squared, and then 10 plus x, not 100 plus x. And if we execute that, it should do the job, and we get x equals -10, or x equals, and that was 3.3 recurring, so that's 10 over 3, 10/3. And clearly it can't be this one, but you should write both solutions down and show this one being discounted. So if x is equal to 10 over 3, we want the dimensions. So we know that h is going to be 10 plus 10 over 3, and that's going to give us 40 over 3. And we also need r, so r is going to be, so that's 10 squared take away x squared, so that's going to be 10 squared take away 10 over 3, squared. So that's 100 take away 100 over 3. And that gives us 300, so that's 200 over 3. Now there's more corrections here. I've just spotted a mistake. First of all, that should be r squared. And of course we should have squared the 3 there. So this would be 900 take away 100, so that would be 800 over 9 for r squared, and then r is going to be the square root of that, so it's going to be over 3. So 800 is going to become root 8 root 100, so that's going to be 10 times 2 root 2, so that's going to be 20 root 2 over 3. Should have done it on the calculator because it would sort that out if I was in standard mode anyway. Now, it does say we need to justify, and in order to do that we need d2v dx squared. Now we can certainly do that on the calculator, so we could do d2v dx squared. So calculation, we want to differentiate, and because we want that, we're going to do squared derivative at a point, and we want that when x equals 10 over 3, variable x, and we just need the expression. I put that in the wrong place, the 10 over 3, so the value is 10 over 3, and the expression here is the one that we have here, so that's 1/3 pi. 1 divided by 3, I might use some brackets here just to make sure. So 1/3 pi, and then we have the 100 minus x squared, and then we have the 10 plus x, and second order derivative, so that's good, and that gives us negative 41 point something, and the negative implies a maximum, so that's the justification part.